Welcome to my lecture online. Now let's talk about what is the greenhouse effect. Well, we can define it as follows. It is the warming of the atmosphere accomplished by the absorption of the sun's energy by water vapor, carbon dioxide, methane, nitrous oxide, and ozone, and then transferring that energy to the other molecules in the atmosphere, which, by the way, of course, make up the vast majority of the atmosphere. Somehow the energy has to go from the sun to these molecules to the atmosphere before it's lost back to space. The longer that energy is kept in, the warmer it'll get before it gets out to space. Again, it's that equilibrium point at which the temperature of the world would then reach its average temperature. So how is that accomplished? Well, first of all, by sending satellites into orbit and measuring the radiation coming from the Earth, we've been able to measure that the atmosphere radiates 59% of the 100% of the energy we get from the sun. 59% of that is radiated back into space, which means that somehow the atmosphere must absorb that 59%. And again, it's the delay factor between the absorption and the readmission that keeps the Earth warm. The longer it maintains that heat, the warmer it can get. We also know that clouds, aerosols, water vapor, ozone, and carbon dioxide directly absorb 23% of the sun's energy. So 59% of it is absorbed by the atmosphere, and 23 of that 59% is directly absorbed on the way in from the sun towards the Earth's surface. So aerosols, clouds, water vapor, ozone, and carbon dioxide absorb already 23% of that, of the total of 59%. Then an additional 30% is sent back into the atmosphere after the heat reaches the surface through evaporation and convection. Convection currents take heat up back into the atmosphere, and evaporation of the oceans, of the Earth, the lakes and the rivers and so forth also provide an enormous amount of energy. So a total of 30% of the incoming energy of the sun, that's almost 1/3, gets back into the atmosphere through these two processes of evaporation and convection. 29% of the incoming energy is simply reflected back into space, either reflected or scattered, so it never comes to the surface of the Earth, it never gets absorbed by the atmosphere, it simply goes back into space. So if we take 100% and subtract from that the 23%, and the 23% here is the 23% that's being absorbed, and then we take the 29%, which is the energy that's reflected back to space. The remainder, which is 48%, makes it to the surface of the Earth. So almost half the sun's energy reaches the surface of the Earth. What happens after it reaches the surface? Well, 30% of that 48% goes back into the atmosphere through evaporation and convection. So of the 48% that make it to the surface, the vast majority of that, 30%, make it back into the atmosphere via evaporation and via convection. So 23% is absorbed on the way in, and 30% is pushed back into the atmosphere after it has reached the surface of the Earth. That leaves us with about 17 to 18% that's reached the surface of the Earth, for which we don't know yet what that's going to happen. So the 17 to 18% of the energy is radiated back by the surface towards space. But does it all get there? The answer is no. 12% of the 17 to 18% that is radiated into space does make it back to space because it has the wavelength and frequency that does not get absorbed by the atmosphere or by the molecules in the atmosphere, and therefore does reach space. But the remainder, if you then subtract 12% from the 17 to 18%, you end up with about 5 to 6% of the radiation that's radiated back from the surface of the Earth that does get absorbed by the atmosphere. So therefore, we can see then that the amount of heat getting into the atmosphere comes from various sources. 23%, let me circle that, 23% is directly absorbed as it reaches the atmosphere on the way in from the sun. Then, going back into the atmosphere is 25% because of evaporation and 5% because of convection currents. So a lot of heat goes back into the atmosphere through evaporation and convection. And then finally, of the remainder of the energy that is on the surface of the Earth that gets radiated back into space, about 5 to 6% is of the correct frequency and wavelength so that it can be absorbed by the absorbing gases, primarily water vapor, carbon dioxide, methane, nitrous oxide, and ozone in the atmosphere that hold back about 5 to 6% that does not make it into space. So these three quantities or four quantities added together, they add up to 59% of the total energy coming from the sun that is therefore absorbed by the atmosphere, and that's what we can call the greenhouse effect. It is what keeps the heat in the atmosphere so that it doesn't readily go back into space, keeping the Earth at a nice, comfortable temperature. At least those are the conditions we find in the atmosphere today.